Welcome to this video on the fifth set of revision questions, and this is looking at two questions coming from the probability section of our course from last year. So the first thing that we are going to look at was the 2017 question. It was from paper 2, section B, and it was question 8. And we're only looking at the second part of it, so part B, which was a probability tree diagram. The second question then we're going to look at is 2014, and it was a sample paper, so it was from paper 2 and it was section A, question 1. So we're going to do that question in full. So let's start by looking at the first question. So in Galway, rain falls in the morning on 1/3 of the school days of the year. When it is raining, the probability of heavy traffic is a half. When it is not raining, the probability of heavy traffic is a quarter. When it is raining there is heavy traffic, the probability of being late for school is a half. When it is not raining and there is no heavy traffic, the probability of being late for school is an eighth. In any other situation, the probability of being late for school is a fifth. Some of this information is shown in the tree diagram below. Write the probability associated with each of the branches of the tree diagrams and the probability of each outcome into the blank boxes provided. So give each your answers in the form A over B, where A and B are both natural numbers, so that's going to be a positive fraction. And the key that they've given us here is rain is or, no or means no rain. T is for traffic, no T is for not heavy traffic, L is for late, and no L is for not late. So this is what they've done here. So at this point, you can see that they've filled in pretty much everything that they told us, which makes our lives a lot easier. There's only one branch here that you need to fill something in. So this is the only one that's blank, and we'll deal with that in a second. Other than that, every branch has one side into it, and that makes our lives much easier, because if you can remember, each branch of the tree must add up to 1. So if here, so just so you can see where I am, I'll just highlight these bits in green. So there's a third. So there's a third, which means that on the other side, so let me just get my pen. On the other side of that, that's going to have to be 2/3. Similarly here, I'm looking at this box here, this is a half, so this must be a half. Here is a quarter, so this must be 3/4. Remember, they asked us not to do it, they asked us to do it in fractional form, so that's what we're leaving it as. Here they've said an eighth, so the rest must be 7/8. Again, I'm skipping where I've highlighted in yellow. Here is a fifth, so this must be 4/5. And here is a half, so here must also be a half. So the only thing now we've left to fill in is the yellow branch there. So I know it's pain because I don't have it here, but if you read back to the question, I'm just going to read through it again. So when it is raining, the probability of heavy traffic is a half, and I'm just going to tick that as we show it. So that one there. When it is not raining, the probability of heavy traffic is a quarter. Sorry, on the first line, which I forgot to read. In Galway, rain falls in the morning on 1/3 of the school days of the year. So then when it is raining, the probability of heavy traffic is a half, so that was that one here. And when it is not raining, it is a quarter, so that's that one here. And when it is raining and there is heavy traffic, the probability of being late for school is half. When it is not raining, so we're down here, and there is when it's not raining and there is no heavy traffic, probability of being late is 1/8. In any other situation, the probability of being late for school is 1/5. So they've put that in once, but the second place where they have not put it in and where we need to fill it in is here. So once that is in as a fifth, we can put in here as 4/5. So that is our tree diagram filled in. Now, although they gave it to you in words, filling it in on the tree diagram, that was really nice, because it meant that you didn't have a huge amount of thinking to do once you remembered that each branch added up to 1. So then to fill in this final box, we have to say what is the probability that it's going to rain, and, so remember and means multiply, there is heavy traffic, and we will be late. So when we do that, that ends up as being 1 over 12. Here we're going to have a third by a half by half, which is the same. It's going to be 1 over 12. Here it's going to be a third. So if you follow your line, it's going to be a third multiplied by a half, multiplied by a fifth, and that ends up being 1 over 30. Here is 4 over 30. This is 2 over 60. Here is 8 over 60. Here is 6 over 96. And here is 42 over 96. Now, if you want to simplify that, that's absolutely fine. The first three are as simple as they can be. This can go down to 2 over 15. This can go 1 over 30. Here, we'll get 2 over 15. Here it can be simplified 1 over 16. And here we get 7 over 16, dividing 6 into top and bottom. So that's just a more simplified version of that. I'm going to be using just the bigger numbers as we work through, but either are completely acceptable at this point. So on a random school day in Galway, find the probability of being late for school. So there's a few different lates. I've put a small version here, so hopefully you can see it. So what I'm going to have is here is where I'm late, here is where I'm late, here is where I'm late, and here is where I'm late. So I could be late because it was raining and there was traffic, or I could be late because there was raining and no traffic. Or I could be late because it was not raining but there was heavy traffic, and so on. So the word or, if you remember, we're adding. So what I'm going to have is a 12th plus a 30th plus 2 over 60 plus 6 over 96. Brilliant. And when I add all that together, I get 17 over 80. And I would leave that as a fraction because they did say when we're filling in the tree to leave it as a fraction. Okay. So the last part of this question then said, on a random day in Galway, find the probability that find the probability that it rained in the morning given you were late for school. So this word given is a huge clue that we're dealing with the conditional probability. So if you remember your conditional probability. Okay, so it's the probability that it rained given, and it was this straight line down, you were late. And that's equal to the probability that it rained and you were late all over the probability that you were late. Now, the probability that it rained and you're late. Let's take a look at that first. So we're dealing up here, it's the probability that it rained and you were late. So we're dealing with this one and this one because they're both dealing with the rain. So we're going to say the probability, so this is equal to 1/12 plus 1 over 30. And that's all over the probability that you are late. Now that was what we worked out in the previous part, which was 17 over 80. Okay, and if you want to put that into your calculator or simplify whatever way you want, that will work out as 28 over 51. Okay, and again I would leave that in fractional form because they were discussing fractional form there. So find the probability that it rained given that you were late for school. So that conditional probability. So the conditional probability formula is really important. You need to know that. And there's a few formulas within the probability sphere that you do need to know. Conditional probability is one, and independence is another. You need to know about mutually exclusive. You need to know about if you're dealing, well, I suppose independence is a version of this. So there are some videos up there going through probability in its totality and all the formulas you need to know with basic examples of each. So if you want to go back over it, do go back. It's on this channel here, and you'll be able to find the video on, I think it's just on basic or introduction to probability. So now let's take a look at the second question that was on that revision sheet. So it said the random variable x has a discrete distribution. The probability that it takes a value other than 13, 14, 15 or 16 is negligible. So basically that's telling us, so x is some number. This number is discrete, so it's not continuous. It cannot take any value. It can only take specific values. So we think of discrete as there tends to be a jump. So for example, when we're counting people, there will be a jump from 1 to 2 to 3. We don't deal in decimal points, we don't deal in halves. So we would consider counting to be discrete. Continuous then is the opposite to discrete, and that means it can take any value, and that's generally any numbers we can measure. So for example, height, you don't jump from one height to another, you grow through all the values. Similarly, weight, distance, speed, all of that will be considered continuous. So here we're talking about a discrete distribution, so it's discrete numbers. So they're telling us it's going to be 13, 14, 15 or 16, and that's it, nothing else in between. So the first thing that I know about this then is if it can't take any value other than 13, 14, 15 or 16, that all my probabilities should add up to 1. So let's take a look and see. So when I add all these together, I will get, one second. So sorry, now get my pen. So if I add 0.383 plus 0.575 plus 0.004, I add them all together, I get 0.962. My full probability should be 1. So if I take that away from 1, and I get 0.038. So that should go in here. So remember, when I'm looking at the all the possible outcomes, then that probability will always equal 1. So the second thing it said, so it said complete the distribution table below and hence calculate EX, the expected value of X. So the expected value of X. So how we do the expected value, if you remember, it's kind of like a version of the average. So what we're going to do, the formula is in the log tables, and it's X times the probability of X. Okay, and it's the sum of all of those. So for us, what that means is I'm going to take my X, my first X value is 13, and the probability of it happening is 0.383. And this kind of E looking letter here, that's our sum, our summation. So we have to add these together. So it's 14 times 0.575 plus 15 times 0.38. Sorry, apologies. Get back my pen. So it's 0.038 plus 16 times 0.004. So when we do that multiplication, we add them all together, we get 13.663. Now, it didn't tell us to do anything regarding rounding or anything like that. However, I wouldn't round it, given that everything has already been to 3 decimal places. We should leave it at that. So that's our expected value. So often our expected value, when it comes up in the questions, it's not as mathematical as this. Like, this is laid out very mathematically. They've shown us what our X is. They've shown us the probability really clearly. It's really easy then to follow when we look at our formula here. So it all kind of ties in. But often when we do expected value, it's asking us in a real practical manner that we maybe have to think a little bit more about. But this is great practice just to remind ourselves what the expected value is. So part B then, it asks us if X is the age in complete years on January 1st, 2013 of a student selected at random from among all second year students in Irish school, explain what EX, the expected value, means. So what the expected value is, and I said it a minute ago, is it's a version of the average. So what we can say is EX, sorry, should be a capital X. So EX represents the mean. So that's the average we're talking about now. The mean of the ages of all second year students in Irish schools on the 1st of January 2013. So notice that I'm just using what they gave us, all second year students in Irish schools. So I'm basically just regurgitating what they said, but I think the big thing to get there is that it represents the mean. So our version of the average that links in here. So it represents the mean of the ages. So expected value is more of a probability term, while mean tends to be more statistical, but this is where they overlap. If you remember back, the expected value when I roll a dice is 3.5, and we talked about the fact that, well, there is no 3.5 on the dice, so what does that actually mean? Because I can't expect to get a number that's not there. And we talked about how it was actually well, what is the mean of all the possible outcomes on the dice, and I suppose that's what this is here. So what is the mean of all possible outcomes? So it says our expected value represents the mean of the ages of all second year students in Irish schools on the 1st of January 2013. So that was a bit of a practical question there, but again, this was a sample. So we tend to get things like that in a sample paper. So part C then, the last bit we're going to look at. If 10 students are selected at random from this population, find the probability that exactly 6, now this should be ringing bells, exactly 6, ding, 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 what are we talking about? So exactly 6 of them were 14-year-olds on the 1st of January 2013. Give your answer correct to 3 significant figures. So what's really important here to note is they said 6 out of 10. They didn't say the first 6. They didn't give us any particular ones that were 14 years old. They just said exactly 6 of them. So we don't want where 7 of them, we just want where 6 of them are. In order to do that, where we want, 6 out of 10, but we don't care which 6, we use what's called Bernoulli trials. Do you remember Bernoulli trials? Hopefully you do. Bernoulli trials. So this is where we're trying to figure out what's the probability of something happening, but we have no idea about the order in which it happens, or we don't care about the order in which it happens. So what we want to see is what is n. So how many times are we doing this? Well, we're talking about 10 students. Or then how many are going to be successful? Well, that's C. P then is the probability of success. So what's the probability that you can be 14 years old? Well, if you go back up to your table, we found the probability was 0.575. We then had Q, which was equal to 1 minus P, so it was the probability that they're not 14. So even though we had lots of different options here, we're just going to deal with just 2 options. 14, not 14. So the probability they're 14 is 0.575. The probability they're not 14 is 0.425. So then the formula, which is in your log tables, is n choose or, p then to the power of or, q to the power of n minus or. So let's sub in 10 choose 6. That's not a fraction, it's our choose, our capital C. So 0.575, and that's going to be to the power of or, which is 6, and then q 0.425, n minus or, which is 4. And when you do that, we should get up with 0.248, which is correct to 3 significant places. So in this case, 3 significant places was the same thing as 3 decimal places, but it won't always be the case. So make sure you're okay with your rounding there as well. So your Bernoulli trials then, this is also known as the binomial distribution. So binomial, bi meaning two. So remember, we can only have two outcomes, and we deal with that as success and failure. In this case, success was 14 years old and failure was not 14 years old.